doing chapter 12, which is stoichiometry, and section 2, which is chemical calculations. And what it is determining the number of moles in a sample of a compound. So you first have to measure the sample and then find the molar mass and then calculate the number of moles in that mass. So on page 360, I'll be doing example 11, and it says, this equation shows the formation of aluminum oxide, which is found on the surface of aluminum objects exposed to the air. So they give us the equation, and the question that we'll be doing is how many moles of aluminum are needed to form 3.7 moles of Al2O3. And so here we have the question again and the equation. So first you take 3.7 moles of aluminum oxide and you multiply it by 4 moles of aluminum over 2 moles of Al2O3. So it'll cancel out here and here, so you'll be left with moles of aluminum, and once you multiply everything out, you'll get 7.4 moles of aluminum. And the second equation, the second example, is number 13 on page 361, which says acetylene gas, C2H2, is produced by adding water to calcium carbide, which is CaC2. It gives us the equation, and then the question is how many grams of acetylene are produced by adding water to 5 grams of CaC2. So here we have the question again and the equation. So first you start off with 5 grams of CaC2, and you multiply it by 1 mole of CaC2 over 72.58 grams of CaC2, and you get this by finding the grams, the amount of grams in CaC2, and then it's in 1 mole. And then you put in a mole bridge. So there's 1 mole of CaC2 in the equation and 1 mole of C2H2. And then you multiply it by 26.04 grams of C2H2 over 1 mole of C2H2. And this is the amount of grams in C2H2. So once you multiply everything out, you'll get 1.81 grams of C2H2. And so that's how you do that. So that's basically how you do stoichiometry and calculating chemical equations.